All right, welcome back everyone. Today in this video, we're gonna look at the zeros of a quadratic. When studying quadratics and parabolas, the zeros are a part of them that we are particularly interested in. The zeros of a quadratic are also called the x-intercepts. So on the graph, they are the x-intercepts that we see. They're also the solutions to the quadratic when we set it equal to 0. So x-intercepts and solutions. A quick example is if we had the quadratic x squared plus 3x plus 2 equals 0. These zeros are going to be the solution. So one way to solve this is to factor it. X plus 2 times x plus 1 equals 0. X equals -2 or x equals -1. So -2 and -1 are the zeros for this quadratic. Graphically, the zeros are also the x-intercepts. So if we graph this quadratic, we end up with a parabola that has x-intercepts at -1 and -2. So that right there is -1. Down here we have -2, and our parabola would look something like this. So the zeros are the x-intercepts or the solutions when we set our quadratic equal to 0. For all quadratics, we're either going to have 0, 1, or 2 zeros. 0, 1, or 2 solutions, we could also say. We can see these three different situations using a graph. First, the 2 zeros can be seen to the right here. 2 zeros are going to happen, or 2 solutions will happen when we have a quadratic that passes through the x-intercept twice. So something like this. Another example of 2 zeros would be if we had a quadratic that was going facing down, maybe, and it passes again through the x-axis 2 times here and here. When we have 1 0, what that means is that our quadratic is only going to pass through the x-axis or touch the x-axis once. So this would be a situation where the vertex of our quadratic is on the x-axis. So maybe something like this, where we start on the x-axis, or another one could be facing down and starting on the x-axis. These are situations on the graph where we have one x-intercept or one solution. 0 solutions happens when our quadratic doesn't pass the x-axis at all. So this happens when our quadratic is kind of floating above or below it. In other words, when we have a vertex above or below it and our parabola doesn't face the direction of the x-axis. So it's above and it's facing up, or below and facing down. For these two quadratics here and here, these will never pass the x-axis. So we have no solutions. So these are the 3 cases we run into. One note is this last case, when we have 0 solutions or x-intercepts, we say that we have no real solutions. We'll learn next year about the imaginary solutions that happen in this situation. So these 3 cases, 0, 1, and 2 solutions, can be seen using a graph. They can also be seen using our recently discovered quadratic formula. So thinking back to our quadratic formula, -b plus or minus the square root of b squared minus 4ac, all divided by 2a. So now we're going to go through the 3 different cases for 0, 1, and 2 solutions, looking at our quadratic formula. First, for 2 solutions, we could look again at our quadratic we had, up here, x squared plus 3x plus 2 equals 0. And then I'm going to go ahead and solve this using the quadratic formula really quickly. Okay, so I just wrote out really quickly. We don't need to go through all the steps. for this, but I wrote out all the steps for solving this using the quadratic formula. So I plugged in our values here and then just simplified until we got our two solutions down here, which are the same solutions we got by factoring -1 or -2. So here's an example of when we have two solutions. Let's look at an example where we have one solution, and we'll also look at an example with 0, and we'll compare the quadratic formula, the work that we do for our quadratic formula, between these three cases and see what is different. So for one solution, an example would be if we had x squared plus 4x plus 4 equals 0. So here again, I'm going to take our a, b, and c values, 1, 4, and 4, plug those into our quadratic formula, and solve really quickly. Okay, so here again, I entered a, b, and c into our quadratic formula. And then finally, we ended up with, on the bottom right here, one solution, -2. So when we were adding and subtracting, we added and subtracted 0. So we got one solution, -2. So we'll take a look at a quadratic that has 0 solutions. We have x squared plus 3x plus 4 equals 0. Again, I'll take our a, b, and c values, 1, 3, and 4, plug them in, and solve using our quadratic formula. Okay, so here, again, I went through the quadratic formula, plugged them in, and then at the bottom, we end up with no solutions. And the reason why we know there's no real solutions is if we look underneath our square root over here, we have the square root of a negative number, which we know isn't possible with real numbers. So at that point, we can stop, say there's no real solutions. In other words, 0 solutions for a quadratic. So I want to look at each case and look at the quadratic formula for each situation. When we had two solutions, let's take a look at our square root. Inside of our square root, we ended up with 9 minus 8. In other words, we ended up with 1 right here. So we had square root of 1. We're going to have two solutions when we're taking the square root of a positive number. So whenever we have a positive number underneath the square root, what happens is we end up with two square roots that we can add or subtract. So we have to split up our solutions into two solutions like we did on the right there. So when we have a positive number underneath our square root, we'll end up with two possible values that we're adding and subtracting. With one solution, we ended up with 0 under our square root. So one solution is when we have square root of 0. What's happening here is because the square root of 0 only gives us one value, 0, we take our -4 and we're adding and subtracting 0, which means we only end up with one number on the top, -4. So we don't have to split it up into our two situations like we did above. The no solutions happens when, well, we noticed that there were no solutions down here by the star when we had a negative number under the square root. So 0 solutions happens when we take the square root of a negative number. So we looked at our three different cases, going back up, graphically. Two solutions is when our graph, our parabola is passing through the x-axis twice. One solution is where the vertex is on the x-axis. 0 solutions is where we don't have any x-intercepts at all. We also looked at these three situations using our quadratic formula, and we found out some patterns for what's happening under the square root in each case. The takeaway from all of this is we can use what's under that square root to give us information and tell us which of these three cases we'll end up with. So thinking about our quadratic formula, again, -b plus or minus the square root of b squared minus 4ac over 2a. So looking at what's under that square root gave us information about the number of solutions we have. So under our square root, we have b squared minus 4ac. So this value, these two terms here, when we combine them, give us information about the number of solutions. And because of that, we actually have a special name. We call this the discriminant of our quadratic. So the discriminant is just the under square root part of it, the b squared minus 4ac. And when we plug in b, a, and c, we'll end up with just some number. Thinking back to our three cases, if our discriminant, b squared minus 4ac, is a positive number or bigger than 0, then we have two solutions. If our discriminant, b squared minus 4ac, is equal to 0, we're adding and subtracting 0. So we don't have to split it up into two cases. We only have one solution. Finally, if our discriminant, b squared minus 4ac, is less than 0, then we're taking the square root of a negative number, which means we have 0 real solutions. And for algebra 1, again, we'll just say no real solutions and leave it at that. So if you're asked to identify the number of solutions, or even if there are any real solutions for a quadratic, instead of filling out the entire quadratic formula and then trying to solve, we can just fill out this discriminant part and use that number to inform us about the number of solutions.